Percent of error is really the same thing as percent of change. Instead of them explicitly telling you how much it changed by, though, they're saying how much was the error. And the amount of error from what it was supposed to be is the amount of change. So if you're confused on kind of filling the gap, make sure you watch the prior video on percent of change before you watch this video on percent of error, and things might make a little more sense. We're still going to use the formula percent over 100 as usual, percent over 100, but on this side we'll use again the amount of change, how much it changed over the original, or the amount of error space over what it was supposed to be. So the amount of change, how much it changed over the original, equals percent over 100. This is the one we're going to use for this particular lesson on percent of change. Percent of change, we use the change over the original. Percent of change is change over original equals percent over 100. It's not new, so if you do new over the original, you will get them all wrong. It's not what the new value is, it's how much it changed from the original to the new, the amount of change over the original. Percent of error is very similar to percent of change, except instead of the amount of change, we're calculating how much it's off from what it's supposed to be. So the change is similar, except it's the error. So it's still calculating a difference from what it was to what it is versus what it was supposed to be to what it actually is. We see percent of error is the amount of error, so like how far off it is, all over the original or what it's supposed to be, so optimal or what it's supposed to be, over percent equals percent over 100. So the amount of error, how much was it's supposed to, so the question says the time it takes to read a paragraph is supposed to be 45 seconds, but it actually took 50. So the amount of error here is 5. So it's 5 off from what it's supposed to be. We're looking for the percent over 100. The optimal is 45. It's supposed to be 45. So it's 5 away from the what it was expected to be 45. We cross multiply, we divide. When you cross multiply and divide, you'll get 11.1 repeating. Make sure you leave the repeating bar, in this case percent. So 11.1% error, percent of error. So it's off by 11%, which is actually pretty significant. And as far as the amount of error, 10% off, more than 10% off. Here's another example. It's common knowledge that the weight of a professional marble is 0.16 or 16 hundredths of an ounce. The Spherosphere company claims that their marbles are professional grade, but the recent batch all weigh 0.15 ounces. What's the percent of error? In this case, it's a negative percent of error. It's on the negative side. We can still calculate the percent of error. The percent of error is still the amount of error over the optimal equals percent over 100, which we're looking for the percent over 100. Now, optimally, it's supposed to be 0.16, but that's not what it is. It's off by 100, 0.01. When we cross multiply, we get 0.01 times 100, which is 1, divided by 0.16, the leftover, and we get, calculating 1 divided by 0.16, we get a 6.25% error. So the error is 6.25% error, which is not insignificant, but pretty obvious. So again, this is just like percent of change, where we're subtracting to find the difference of what it was supposed to be versus what it actually turned out to be. Over optimal, the original thought on what it was, equals percent over 100. We still cross multiply and divide to find our answer.